Word problem number 2 says that a particle works up and down a vertical line like this somewhere. It's moving up and down. And we don't exactly know how, but they give us a formula. And they say y equals t cubed minus 12t plus 3. Being a cubic function, that means that over time, definitely it's going to be going up. Nothing's going to stop it. But early on, this minus 12t is probably in charge. And you should be able to look at that just by the algebra, because if time is 1,000, you're going to get like 1 billion here, and this is going to be like plus 3. So certainly this particle is moving down, and then it's going to move up. Now it's all on a vertical line here, so don't draw a parabola per se, other than be looking at it over time. So first it's going to go down, then it's going to go up. Let's figure out how and where and what it is they want from this. They say the particle moves on a vertical line. Find the velocity and acceleration. You remember from the physics explainer video I did, because I'm sure you've watched, I believe at this point it's all 114 calculus videos I've made, that the velocity is the derivative of distance, or displacement is a better term, but for now they're the same to you. So we just use the power rule and we find that the velocity is equal to this, 3t squared minus 12, and the acceleration is the derivative of velocity, so that's just going to be 6t. And already it's become very simple, but what this says is the acceleration is always in the up direction. That means just like a rocket, maybe it's falling to Earth, but as long as you're hitting the gas, it's trying to climb. And maybe by trying to climb, it's slowing down its fall first, then kind of hits a critical point and then begins to climb. That's how objects work. So they're saying to us that here's what's going on. And then for part B, they say, when is the particle moving upward and when is it moving downward? Well, we already kind of determined that it'll be moving upward in the end for sure. So let's assume it's moving downward, but it doesn't really matter. We could figure it out. And then it's going to climb upward. And again, it's a vertical line. I'm just drawing the parabola because this is over time, like 1 second, 2 seconds, 3, 4, something like that, seconds as we're watching its height, so that we can kind of illustrate what's going on here. Well, let's start at t equals 0 and figure out where it actually is. That's 0, 0, plus 3. So this is at a y equals 3 when time equals 0. Okay. And they say, when is it moving upward, when's it moving downward? So at some point, as it's falling, it's going to hit this kind of critical point, I believe is the term we use. And the way we find that is you notice the slope of the equation here is going to be 0. It's flat. Well, that's the velocity is the slope of the displacement. So we set that to 0. 3t squared minus 12 equals 0. And when I move the 12 over and divide by 3 and take a square root, you're going to find pretty quickly that time equals 2. Very basic algebra, right? So we can write here time equals 2. And my y value, well, we could just plug 2 in here. So that would be 8 minus 24 plus 3. 8 minus 24 plus 3, that's negative 13. So the total distance traveled here, y2 minus y1, that's a 16. That's how far it's fallen. They say, oh, real quick here to finish part B, your answer to that would actually be downward is when time is less than 2, and upward is when time is greater than 2. Now notice it's not greater than or equal to or anything like that, because at exactly 2 seconds there is no velocity. Okay. So they say find the distance that the particle travels in the time interval from 0 to 3. So they want to find out when time equals 3, what's my y value? So put in 3. 3 cubed is 3, 9, 27, minus 36 plus 3. Let me see if I can do that off the top of my head. 27 minus 36 plus 3. I want to say that's negative 6. And that makes sense, which means it's been climbing from negative 13 to negative 6. What's that distance? Negative 13 minus negative 6. or the other way around, sorry, negative 6 minus negative 13, that's a distance of 7. So here it traveled 16 down and 7 up. That would add up to a distance of, I'll just write d equals 23. That would be the answer to that question. But you notice that if you did not find the critical point here, you would just simply take this coordinate and this coordinate and find this height difference of 10. And that's how your teacher is going to know you're full of BS. Because the distance it traveled is a lot more than 10. First it traveled down, then it traveled up and undid some of that displacement, but the total distance it traveled is all of those added together. And the trick to this is find when the velocity is equal to 0, find out how the time separates the downward and upward trajectories, and then calculate them separately to find the results to this problem. It's a good word problem.